Online students, am I audible and visible? Yes. So, though our classes are over, hope you have revised at least once what we have discussed in class, or at least attempted the question paper well. Yes. So, let's start the test discussion. We'll start with the MCQs. First MCQ that was there for the last week, the weekend test, was which type of the fuel cell operates at the highest temperature among the following? Maybe and some dot. Okay. Yes. So hope you have answered it. As I tell you, always keep noting down the current affairs on SNT as well. So this question over here talks, it was asked, fuel cells are asked mainly in previous year questions and it is in news always. So which fuel cell operates at the highest temperatures among the following? First, what is the basic understanding that you should have? Any fuel, I told you, calorific value, when it is high, it will give us high temperatures. Yes. So what did we see? We have seen that the solid fuel in propulsion system, it has high calorific value. Yes. Why? It burns evenly. And it is more stable and hence has high calorific value. Now, if it is a proton exchange membrane fuel cell or a molten meaning liquefied, then solid oxide fuel cell, alkaline fuel cell, the answer will be solid oxide fuel cell. Yes. Then consider the following differences between jet engines and the rocket engines. Oxygen source for a jet engine is taken from, yes, online. Jet engine is taken from the atmosphere. We have seen that the fuel does not consist of a oxidizer, whereas in rocket engine we have discussed that the oxidizer as well as the fuel are combined together. So if you see the first matching, both of them are rightly matched. The jet engine takes the bless you. Sorry, excuse me. The jet engine takes the oxygen from the atmosphere, whereas the rocket engine has the oxygen or the oxidizer combined with the fuel itself. Yes. Next, we have air intake. So we said in jet engines, we have seen in the propulsion system, in the ramjet and the scramjet engines, is there any air intake that is happening? If you remember the ramjet and the scramjet engines, how does the propulsion system look? Yes, we have placed a fan, we have connected it. Yes, we have seen the cross section as well, where you have gap, and then we have extra compressors. Yes, we have injected the air. That means, does it have air intake which undergoes a adiabatic compression that takes place? This is a ramjet engine. Remember something like this? We have talked about it. Yes. So in a ramjet engine, the air intake takes place, and in scramjet, I told the same thing without the extra compressors. Whatever is this, and then just this much. Yes. So if this is in place, so we all know that it is scramjet that is in place. Okay. Then what else? What else are we aware of? So the question is asking whether a jet engine takes air for its propulsion system. Yes, we have seen that a jet engine takes, and the rocket engine does not take. So if you see the matching question that is asked, if you have to write a mains answer also regarding what are the differences between a jet engine or a rocket engine, then you can easily have that same tabular format that is given in the question. You can use it as an answer in your mains answer. Then suitability for high space flight. Is a jet engine suitable for high space flight? Yes or no? Yeah. So it is not suitable for a rocket, no air intake. High space flight is possible only in the rocket because it carries its own oxidizer. In high space, you will not have atmosphere. The atmosphere is missing, is not there, and hence you will not have the presence of oxygen in the high space. So only the engines which carry their fuel as well as these oxidizers with along with them, they will be only going to high space flights. Then the application of jet engines is used in commercial aircrafts, whereas rocket engine is used in spacecrafts as well as missiles. So both of them are true. So if you see which of the following is the correct comparison, then all four is the right answer. That is the fourth option. Yes, I hope that answer or that question was easy for you to solve if you remember all of these things. Then, which of the following missions were launched from Satish Dhawan Space Center? Okay, for that you should have an understanding of which space station launches what all. We have, if you remember, we have talked about launch stations and how do we mark launch stations. Yes, we said it should be on the eastern side. For what? Yes, for maneuvering purpose. So Satish Dhawan Space Center is here. And then we have something called as Tumba. But we know Tumba only launches sounding rockets. And sounding rockets are those rockets which study the ionosphere in the atmosphere. Yes, the ionosphere in the atmosphere. It is also called as it is also called as vertical profiling of atmosphere. Hope you are able to recollect when I'm speaking these words. That was the intention of all the classes that we were taking. And now, when you know only, we have only this, and then we said one more launching station is again, we started to build it in Tamil Nadu, in Kulasekara. Kulasekara Pattinam. So these are the three launching stations that we have. Now we know only Tumba. This is not yet operational. It is still under construction. Only operational are these two, out of which one is used to launch only sounding rockets. Then the answer should be for Mars orbiter mission Chandrayaan 1 and Gaganyaan 1. All the three were launched from Satish Dhawan Space Center. So the answer will be option 3, A, B, and C. I hope that is clear. Do you have any doubts still here? Let me know if you have any doubts still here. Yes, otherwise we will move on with the next question. Fourth question. Which of the following launch sites in India is used primarily for missile testing? Okay. Now we know about the launch stations. But what about missile testing? So this missile testing in India is done from Abdul Kalam Island. We have named the island on the name of a former president of India. Yes, Mr. Abdul Kalam. So it is located, where is it located? Yes, off coast of Odisha. And who operates missile launching or missile testing? The Defense Research Organization, DRDO. Yes. Formerly, what is it called as? Online. Formerly, what is it called as? Same island was formerly called as Wheeler Island. So any of the names you should be able to identify where the testing is happening. These are some factual things that might be asked in the preliminary examination. So just remember what is the name, what is the previous name of the island where the missiles are tested, what is the new name that has been given. Yes, Wheeler Island to Abdul Kalam Island. Where is it located? Off coast of Odisha. Who operates it? Functioning, it is DRDO, not ISRO. ISRO only for launch stations. Missiles is the Department of Defense Organizations. Then we'll go for the fifth question. Match the following Indian rocket launch sites with the corresponding characteristics. Satish Dhawan Space Center, is it located in Thiruvananthapuram, or is it a missile testing facility, or is it located in Sriharikota Island, or is it a private mobile launch pad? Yes, it is located in Sriharikota. We have discussed this in class. Then Vikram Sarabhai Space Center is located in Vikram Sarabhai Space Center is the same as the Tumba. Tumba has been renamed as Vikram Sarabhai Space Center. Yes. So where the sounding rockets are launched. So it is located in Kerala in Thiruvananthapuram. Tumba is in Thiruvananthapuram, which is in Kerala. Okay. Next we have Abdul Kalam Island. As we have seen, it is a missile testing facility. And Agnikul, we have seen Agnikul where? Agnikul is a private defense, sorry, private space testing agency. Remember seeing Agniban from Agnikul? Agnikul is the name of the space, private space organization. Yes, the name of the launch vehicle is called as Agni Ban. If you remember the picture, it was matte black in color. Hope your pictorial memory is helping you remember it. So that is a private mobile launch pad that is there. Then, which of the following satellites were developed with international collaboration? Megatopics, Saral, YouthSat, HumSat. So these are a few weather satellites, yes, that we know of. Now, Megatopics, do you remember me mentioning Megatopics in the class while we are discussing satellites? Megatopics, what does it do? It analyzes the cloud pattern. Where does it analyze? In the tropical regions. So we have developed it using or collaborating with France. So this is a collaboration with France. Then what is the second one? Saral. Saral again is in collaboration with France, which also is used for remote sensing. Yes, we have Saral. Saral again is a collaboration with France. Then what do we have? Third one. YouthSat. YouthSat again is from Russia. Then HumSat. Yes, HumSat. HumSat is from Netherlands. HumSat is from Netherlands. So these again, whenever they are in use, they become very, very important. What else? Next question. We'll move on to the next question. So all of them have international collaboration. Which of the following ISRO centers are located in Thiruvananthapuram? We have seen the sub-centers of ISRO. How many of them are located in Thiruvananthapuram? Yes. Vikram Sarabhai Space Center? Yes. ISRO Propulsion Complex? Where is ISRO Propulsion Complex located? It is located in Mahendragiri Hills of Tamil Nadu. Whereas the Vikram Sarabhai and the IIST and LPSC, all of them are located in Thiruvananthapuram. So you will have to look at all the locations, remember them for preliminary examination. So why is this paper looks very simple if you have gone through the facts? If you have not understood the minute details or the facts that I've mentioned during the class or only concentrating on the analysis part, then again, factual knowledge is quite important for preliminary. Even if you know 100 things about the organization, which subcenter functions, in which way, what is the function that it has, still you will have to know where is it located. Yes, the location becomes important. Then consider the following statements regarding Astrosat. Astrosat was in use last year. So it has a mass over 1500 kgs. The satellite Was launched in 2015, yes. It was a mass of 1500 kg, yes. Its operations are managed by ISRO's MOX and ISTRAC. Both of them are true. So, three of them are true. So, all of the options are correct. Then, why are microwaves suitable for use in GPS and satellite communication? What are microwaves? Yes. What are microwaves? We are aware that microwaves, I told you, are a subset of radio waves. So instead of me asking about radio waves directly, because you are very much fond of or very much used to the word radio waves, you understand its properties. We have changed, or I have changed it to microwaves, because you should be remembering the fact that microwaves are a subset of radio waves and they have long frequency or wavelength. Long wavelength, not frequency. It has less frequency. Remember what it does? Long frequency, number of cycles or more. So for one cycle, it is starting from here to here. If one cycle takes this time, yes, and higher frequency, that means lower wavelength. So the same, the information to be transferred in 4 cycles only travels to this distance. So you can see the distance it can travel when it has higher wavelength. The energy is mostly lost during higher frequency. Yes, that means they're high energy waves. So for long distance transmission of data, long distance transmission of data, we require microwaves or radio waves for satellite communication. Yes, so that was again the intention behind the question. I hope you've marked this right as well. Then the next question. Uh, the ability to be focused into narrow beams reduces signal loss over long distances. Option 3 for question number 9. Question number 10. Consider the following statements regarding types of satellite orbits. Remember, so polar orbits have an inclination close to 90 degrees, allowing global coverage. Yes, remember poles. So the angle that is making is approximately 90. So it has global coverage. Then geostationary satellites revolve synchronously with Earth and are used for constant surveillance of a fixed area. Remember that? So if you're talking about India and you're placing a satellite on the geostationary, it will have the same angular velocity. Velocity is same, and hence it will have same rotational time period of the Earth. And because it has the same rotational time period of the Earth, it always, the surveillance that is happening is always at a fixed place. Yes? Then, what is option statement C? So both A and B are true till now. Molniya orbits are suitable for the equatorial communication due to their low inclination. Now, what are these? Yes, these Molniya orbits are those orbits which have high inclination. That means they do not make an angle of 90 degrees. Instead, they have an inclination of more than, say, 130 degrees or 140 degrees. Yes, they are called as Molniya. And they are not, because of their high inclination. You can see that the angle that it is making with the equator, if it is high, that means they are obviously not equatorial orbits. They are part of polar orbits. Then, so obviously C becomes a wrong statement. Then D, medium Earth orbits are used in global navigation systems like GPS and GLONASS. Remember medium Earth orbits? Do we remember them? Medium Earth orbits are those orbits which are a little high of low Earth orbits. Why are we going there? We know that the communication becomes very easy when we are in the low Earth orbits. Then why choose medium Earth orbits? For high area coverage. Earth surface. What did we say? If we place a satellite A in the low Earth orbit, what is the area it covers? That is smaller when compared to you placing satellite B in a medium Earth orbit. Yes, its surveillance or the area of its surveillance is higher. So, for covering such big areas, you require rising the height of the orbits, and hence we have seen all the global navigation systems have chosen medium Earth orbits. So GPS is a global positioning system, is the global navigation system of USA. GLONASS is, the full form is Global Compass. It is by Russia. So you'll have to remember that also such kind of matchings are again and again asked in Group 1 examinations of prelims. So accordingly, option 1 is correct. That is statement A, B and D only are correct. Option C is wrong. Then we'll move on to the 11th question. Match the satellite missions with the orbits they are placed in. Yes, the first one is Aditya L1, which is placed in a halo orbit at the Lagrange point L1. Remember the halo orbit that we are talking about? I held the pen like this, telling that if we are placing the observatory or the solar probe that we want to place, that which the orbit which is perpendicular to it is called as a halo orbit. Yes. So then OneWeb satellites, they again means OneWeb is like Starlink. So they are for providing internet. So they are placed in higher communication, faster communication, low Earth orbits. Then GSAT 10 is for surveillance, military surveillance. We have spoken about communication purposes. So that means it requires a precisely high coverage of the area. So it is placed in geostationary orbit and it completely analyzes a fixed area, that is the country, the whole country. And then Galileo is a, yes, navigational system. It is placed in, where are the navigational systems placed? Just now we've discussed medium of orbits. Yes, so that way, if you see A is matched with 1, B is matched with 2, and C is matched with 3, and D is matched with 4. So option 1 is right. Moving on. Which of the following ISRO satellites is placed in low Earth orbits for disaster management? Now, you have two options how to answer this. GSAT 29, we know all the GSATs are for communication purpose, not for disaster management. Then Aditya L1 is a solar probe. Yes, it is not for disaster management. Then we have INSAT 3D and RESAT 2B. If you see, INSAT again is a communication satellite. Yes, Indian satellite GSATs are replaced and they are being, or INSATs are being replaced with GSATs. Just the name has been changed. So they're all surveillance satellites. So for disaster management, what do we have? We have RESAT, which is a remote sensing satellite. Now, what is the latest one we have? And it is a collaboration with excuse me. Yes. Then moving on. The global navigation systems match it with their countries or regions. As I told you, Galileo is from, it's a global navigation satellite system. Galileo is from EU. Then BEDO is from China. GPS is from USA. NAVIC is India. IRNSS has been, the name of the IRNSS has been changed to NAVIC. We have discussed this as well in class. Yes, so try to revise these things. The option here again is option 1, A3, B1, C2, D4. Then question number 14. Is an assertion reason type of question. The second generation NAVIC satellites are equipped with L1 band payloads because L1 band is globally compatible and supports wider civilian application. Does that make sense? Why L band? L1 band? Yes. So now the assertion is true that we know the second generation NAVIC satellites are equipped with L1 band payloads. Yes. Then L1 band is globally compatible and supports wider civilian applications. So both of them are true, and the reason is explaining the assertion. So option 1, both A and R are correct, and R is the correct explanation of. Then we'll move on to the next question. How does second generation NAVIC improve upon the first generation? What did we say? It adds L1 band compatibility and uses ISRO developed atomic clocks. Remember? We have talked about the error of rubidium clocks. So to avoid or to minimize the error, we said we will use quantum principles. Quantum principles, wherein we will use entanglement, superposition. Using these two principles, we will make atomic clocks. So these atomic clocks will be used or will be replaced in the second generation navigation systems of India. That is the NAVIC. Moving on to the 16th question. Gagan is the satellite-based augmentation system developed jointly by, yes, ISRO and, remember we were talking about the traffic management using the satellites. Yes. So in that we talked about the road traffic, rail traffic and air traffic. So ISRO and Airport Authorities of India. Yes. Then why are composite materials increasingly used in launch vehicles? Composite materials, remember? Sorry. What are composite materials? They use carbon nanotubes. Yes, they are high, they have high strength, high conductivity. Yes. Efficiency is very high. Friction is very low. So they offer high strength to weight ratio. That means they're very highly strength. They have a great strength to the amount of weight that they have. That means they're light in weight also. Yes. So they have cheaper than traditional metallic alloys. They're easier to recycle post emission, which are all wrong. They offer high strength to weight ratio, essential for performance and efficiency. That is option 2. Then 18th question. What is the role of ammonium perchlorate in solid propellants? Remember, ammonium perchlorate is used as oxidizer in solid propellant systems. Yes, then consider the following statements. Solid fuel missiles can be launched more quickly than liquid fuel missiles. Okay. which is true because of its high calorific value, and it brings stability to the bottom, or the center of gravity is focused at the bottom, which gives it, remember we were talking about the stability that it happens because of the weight is concentrated at the base of the rocket. అదే మన రాకెట్ మనము దివాళీలో యూజ్ చేసే రాకెట్ చూస్తే ద వెయిట్ ఇస్ కాన్సన్ట్రేటెడ్ ఆన్ ద టాప్ అండ్ హెన్స్ ఇట్ ఈస్ నాట్ ఏబుల్ టు స్టాండ్ ప్రాపర్లీ. Yes, the center of gravity has been shifted to the upper direction. So it goes in any which way. Not desirable for us. So the second statement says solid fuel missiles require fueling just before launch, making them logistically complex, which is wrong. Liquid missiles have this problem, and that is why we want to shift it to cryogenic and semi-cryogenic. Yes. So whenever you are using liquid fuels, even in cryogenic, when you're using a liquid compressed fuel, they have the high probability of becoming corrosive. That means they react with the atmosphere and they become highly corrosive, which will lead to various accidents, and hence they have to be logistically simple. To make them logistically simple as well, we most of the times for safer things we use solid fuel. If you see in Gaganyaan, see what are the things or the fuel propulsions we are trying to use. Okay, then which of the following types of fuels? So the answer will be one only. The second statement is wrong. The liquid fuels are complex, are highly corrosive in nature, making them logistically complex. Then moving on to the last question of the discussion for MCQs. Match the following types of fuels with their characteristics. One is cryogenic fuel. It combines solid fuel with the liquid oxidizer, or it is stored without refrigeration, or what is it? It requires extremely low temperatures. Cryogenic, it requires extremely low temperatures. We have said almost absolute zero. Yes. Then we have hybrid fuel, which combines both the solid fuel and the liquid oxidizer. Then storable liquid is stored without refrigeration. So these are different types of propellants that you have to know about, and a few details and factual information for the preliminary examination. Then we will move on to our mains questions that are asked. So fuel cells have potential application in both civilian as well as defense sectors. What are fuel cells? In economy, when you get to see the green hydrogen mission, yes, what happens in a fuel cell again? We will use hydrogen as fuel. Mostly we are using them in batteries of EVs, electric vehicles. So what happens? You use hydrogen as the fuel for combustion, and for combustion what do we need? Yes, we require oxygen. Combustion ante enti? Okay, that means we require oxygen for combustion. So what is produced along with heat? So when there is a lot of heat and the outcome is water, what is it converted into? Water vapor. So if you are using this as fuel in your cars using fuel cells, what happens? There will be no release of greenhouse gases into the atmosphere. Yes, so this is one of the green fuels that we are looking at. We are trying to shift from lithium ion batteries that we are using in the electric vehicles to fuel cells, where we use hydrogen as the fuel, and the outcome will be water vapor, which is again a clean gas. Okay, so this is what is a fuel cell. Now we are aware of what they are. So you write what is a fuel cell in the introduction. In the introduction you will be writing what is a fuel cell and how does it work. It is a electrochemical reaction that occurs in the fuel cell where the hydrogen is converted into electricity with high efficiency and low environmental impact. Now, what is it? What is India aiming at? Now you will connect. Now in the introduction, as I always tell, first you will write what is the basic key concept that we are asking in the question, that you will identify. Here the key concept is about the potential and applications of fuel cells in various sectors, be it civilian or be it defense. Then what is the key word? Examine. Examine means, yes, you will write both the positives or negatives of using it in both the civilian and defense sectors. Now, civilian applications are what? సివిలియన్ అంటే మనం రోజు వాడే పద్ధతిలో ఏమేమి ఎక్కడెక్కడ వాడతాం ఫ్యూయల్ సెల్స్? ఒకటి, క్లీన్ ఎనర్జీ కన్వర్షన్ కోసం, అంటే ఎలక్ట్రిసిటీ ప్రొడక్షన్ కోసం. క్లీన్ ఎనర్జీ, మనం ఇంట్లోకి వచ్చే మన ఎలక్ట్రిసిటీ ఏదైతే ఉందో దాన్ని కూడా మనము ఫ్యూయల్ సెల్స్ వాడి జనరేట్ చేయొచ్చు, ఆ హై లెవెల్లో ట్రాన్స్మిషన్ చేయొచ్చు. So pilot projects are already taking place. You can see, you can refer to your model answers for the recent developments. You will have such examples in and out. I mean, almost every month you will have 1 or 2 examples of such kind. I have given you a few examples in the model answers, like the pilot project of Ladakh. Yes, Ladakh and Northeast India, they are exploring small scale hydrogen fuel based microgrids. Chinna grids ante transmission grids kuda they have set up. Let us see if the efficiency is not too high, so we will have to wait and watch to make them highly efficient. Only then we will be able to talk about a larger scale production of energy from the fuel cells. But in civilian applications, there are pilot projects that are being run already for electricity production. Then the second application is public transportation. I've told you, now in a car, you can, instead of using a lithium ion battery, you can use a hydrogen fuel battery. Now, when you're using a hydrogen fuel battery, what happens is you have to understand that especially for public transportation, the buses that are going on, TGRTC, APRTC, ఏవైతే బస్సులు ఉన్నాయో వాటిని ఎలక్ట్రిక్ వెహికల్స్ గా కన్వర్ట్ చేసే ప్రోగ్రామ్స్ ఆర్ దేర్ ఇన్ ఎవ్రీ స్టేట్. Now, when you're trying to turn them, we will better turn them into a hydrogen fuel battery system where the emissions of that particular transportation system are very, very carbon neutral. Yes, because India aims to become net zero emissions by 20. Then we use it for backup power. That means we use it in inverters or as battery backups, and they can be used for ఎక్స్ట్రా బ్యాకప్ సిస్టమ్స్. ఈవీస్ లో మనం ఎట్లయితే ఎక్స్ట్రా బ్యాటరీ పెట్టుకొని వెళ్తామో, ఎక్కడైనా ఛార్జింగ్ అయిపోతే ఎక్స్ట్రా బ్యాటరీ యూ విల్ రిప్లేస్, యూ విల్ పుట్ దిస్ ఆన్ ఛార్జింగ్ అండ్ యూ విల్ మూవ్ ఆన్. ఎస్, సో ద సేమ్ థింగ్, యూ కెన్ స్టోర్ ఇట్ యాజ్ యూ కెన్ స్టోర్ ద ఎనర్జీ ఇన్ బ్యాటరీస్ as well. Then we use it for industrial purposes where we ఎక్కడ మళ్ళీ చిన్నగా ఎక్కడైనా ఎలక్ట్రిసిటీ ప్రొడ్యూస్ అయ్యి ఇండస్ట్రీలో, ఇఫ్ యూ నీడ్ ఎలక్ట్రిసిటీ to decarbonize the sector, heavy industries like steel, cement lo ekkadaina burning kavali, high temperatures have to be released, you can use the same method where the heat is one of the byproduct. Yes, then in defense fuel cells ekkada vaadtam. Remember, I told you nuclear powered submarines. So instead of nuclear powered, can we try fuel cell submarines? అండ్ మనకు కావాల్సిన ఏదైతే హైడ్రోజన్ ఉందో, మనము గ్రీన్ హైడ్రోజన్ మిషన్ త్రూ అక్కడ ఆల్రెడీ ఉండే సీ వాటర్ ని డీసాలినైజ్ చేసి, సబ్మెరీన్స్ వాటర్ లోనే ఉంటాయి, సో వాటర్ నుండి బయటికి రానవసరం లేదు, డీసాలినైజ్ చేసి వాటినే హైడ్రోజన్ ఆక్సిజన్ కింద మార్చి దాన్ని ఎలక్ట్రిసిటీ ప్రొడ్యూస్ చేసుకొని, they will all, what the release is water vapor and heat, which is much better than the nuclear waste that is disposed. Yes, and then unmanned systems and surveillance drones lo, UAVs lo kuda batteries ki, electricity systems ki and the sensors ki we can produce a small level of energy from the fuel cells. Then portable power for soldiers. Soldiers can carry their own fans and lights along with them if they have a small battery, or when such kind of hydrogen fuel cells are portable in nature. Manam phone mobile ki man portable chargers etla aithe carry chestamo, same way we can get for fans and lights also, లేకపోతే స్టవ్ ఎక్కడైనా ఎలక్ట్రిక్ హీటర్ పెట్టుకోవడానికైనా, because it soldiers again in defense sector, we know the terrain that they travel in and they live in is very very harsh, so they'll have to keep moving, and they can actually use such kind of systems or technology for various purposes. So these are the various applications. Now how do you conclude? Just because the question is asking about both the civilian and defense, you will have to conclude saying that this strategic convergence of energy is highly important for both clean energy as well as national security priorities. So developing such technologies will converge both the needs of creating clean energy as well as national security problems, and hence you can make a gist or make a small concluding statement depending on the applications that you have written in the answer. Then we'll go to the next question that is asked. Global navigation satellite system are emerging as strategic assets. Examine India's approach with special reference to NAVIC. Again, we have discussed a lot about global navigation systems, GNSS. They serve as strategic assets. What is the highest, what is the major application that we have about global navigation systems? What are the minimum number of satellites that are required for global coverage? Yes. So every country and the number of satellites Earth should to pedte, then what will be the problem? So instead of that, we wanted collaboration. So for collaboration, what we do? We will give the data, we will share the data that we are collecting to all countries. So such countries which are collaborating for navigational services provide చేసేవన్నీ global navigation systems. We have talked a lot about it just now in preliminary questions as well. So now they're all satellite based systems. They provide geospatial positioning, navigation, positioning and timing. If you remember the space time continuum that we talked about, they require different kinds. ఒకటి length, breadth, height కాకుండా fourth is time. So ఆ ఉన్నప్పుడు correct location along with the timing so that you can track the path. Yes. The tracking can be done using the navigation systems. So strategic importance of GNSS globally is what? It is used for different defense operations. It is used in aviation, ante mana ఫ్లైట్స్ ట్రాఫిక్ మేనేజ్మెంట్ లో యూజ్ చేస్తాము, మ్యారిటైమ్ లో యూజ్ చేస్తాము, నేవల్ దీనికి యూజ్ చేస్తాం పొజిషనింగ్ కి. ఎస్, అగ్రికల్చర్, డిజాస్టర్ మేనేజ్మెంట్ లో. Then we also use it in లాజిస్టిక్స్ పర్పస్. ఇప్పుడు మనం గుర్తుంటే గవర్నమెంట్ సెండ్స్ అ లాట్ ఆఫ్ లాజిస్టిక్స్, అంటే లాట్స్ ఆఫ్ గ్రెయిన్స్ ఫర్ ఫుడ్. ఎస్, ఫర్ పర్పస్ ఆఫ్ ఫుడ్. ఇట్లాంటి అంటే మనం ఫుడ్ సబ్సిడీస్ ఇవ్వడానికి చాలా రేషన్ ఇవన్నీ మనం సెండ్ చేస్తుంటాం. సో అవి ఎక్కడ మిస్యూజ్ అవుతున్నాయో వాటిని ఎట్లా ట్రాక్ చేస్తాం? యూజింగ్ గ్లోబల్ నావిగేషన్ సిస్టమ్స్ వీ విల్ బి ఏబుల్ టు డూ ద సర్వైలెన్స్ వెరీ ఎఫిషియెంట్లీ. ఎస్, సో ఇవి ఇంకొన్ని అప్లికేషన్స్ ఎకనామిక్ సెక్టర్లు. దెన్ ఇండియాస్ అప్రోచ్ ఏంటి? జిఎన్ఎస్ఎస్ అండ్ నావిక్ ఏంటి డిఫరెన్స్? నావిక్ మనకు తెలుసు, మనం ఆల్రెడీ డిస్కస్ చేస్తున్నాం క్లాస్ లో. ఇట్ వాస్ అన్ ఇమీడియట్ ఆర్ అన్ emergency situation that we had to create NAVIC because GPS was not giving us the exact locations or the clear mapping of the terrain during the Kargil war, and hence we had to come up with IRNSS, which is not a global navigation system, it is a regional navigation system. From there we suddenly started shifting with time to NAVIC, where we have 7 satellites in total in geostationary as well as in geosynchronous. 3 are placed in geostationaries, 4 are placed in geosynchronous orbits. Now, what is the objective? To have self-reliance over navigation systems, especially during military ops. Yes, so these are a few things that you will write, and how NAVIC is used for strategic applications as well as for civilian uses. Then we will conclude the answer using or telling that this GSNSS, which was once now used only for a navigational purpose, now it has become a proper, like something that will help you maintain your national sovereignty as well as technological power. So India's NAVIC represents a bold stride towards strategic autonomy, ensuring critical defense as well as economic sectors. They are not vulnerable to external denial. సో మనం ఏదైతే ఫస్ట్ ఉన్న ఛాలెంజ్ కి ఓవర్కమ్ చేయడానికి వచ్చే తీసుకున్న డెసిషన్ ఉందో దట్ ఓన్లీ వి విల్ బి డూయింగ్. ఎస్, సో దీస్ ఆర్ okay. So these are the questions. So online students, if you have any doubts regarding the class or the questions, you can just, I'm unmuting them. So you can unmute yourself and I'll take the questions. Yes. Online, no questions? All clear? So if there are no questions from online and offline, then we will conclude the class. All the very best. I hope this week also you have test in SNT. Please attend the test, write the test so that you will have an understanding of how much and where you are lagging and you can get a real-time feedback of your performance. Thank you very much. Thank you.